This is Mr. Erlin talking about 9.7e, how we use trig to solve for missing angles. The idea is very similar. You're going to be given a right triangle, and you're going to be given certain information. You might be given that, for instance, BC is equal to 12, and you might be given that AC is equal to 5, and what you're asked to find is an angle this time. But it starts the same way. We have to put in our information. So BC from B to C is 12. A, and again, I sure recommend you draw this. Don't try to just do this in your head. AC is 5. A to C is 5. And we're looking for the measure of angle C. Here's C. This is the angle C. So I'm going to put an X right in there. That's the angle we're looking for. The next step is to draw on the little eyeball. This is our perspective. This is the angle we care about. Relative to this angle, I have to label all these sides as opposite, adjacent, or hypotenuse. This is the hypotenuse. It never changes. It's always the one opposite the right angle. If this is my angle, the one way over here, not touching it, that's the opposite side. And the side right next to us here, this is the adjacent side. Now I have to pick which trig function to use. Well, I've got a number value for the hypotenuse, so I want to use the h. I've got a number value for the adjacent, so I want to use that one. I don't have any value for opposite. It's blank. It doesn't help me in this case. So this is what I'm aiming for. Is that a SO, CA, or TOA scenario? Well, I've got an O and an H in SO, but I don't have an O and an H. CA, that's the one I'm looking for because I've got the AH. So I'm going to add a C. And the minute I add a C, I'm telling myself which of these trig functions I'm going to use. Is it sine, cosine, or tangent? And that's cosine. Always, 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 after the trig comes the angle, which in this case is the unknown. And then it's the ratio of these in order, A over H. So that would be adjacent, 5 over hypotenuse, 12. Now, that's the end of the geometry, sort of. Now we have to solve this. And the goal remains the same algebraically. We're trying to find the value of x. We want to get x all by itself. Right now, it's not by itself. It has this cosine next to it. So we have to take this cosine away. But the question is, how do we take it away? If it were being multiplied, we'd divide. But cosine is not a number. We can't divide by cosine because it's like dividing by square root or something. Cosine is an operation. It takes an angle and it changes that into the ratio of the sides. It's a numerical impact that it does to it. Therefore, if we want to get rid of the cosine, we have to uncosine. We have to do the inverse function. It's called the inverse cosine or the arc cosine. And if I do it to one side, I have to do it to the other side as well. And I put it up here because it really belongs in front of this, but I just can't fit that the way I drew it. So these two parts cancel each other out, leaving just x equals. And on this side, I'm left with the cosine inverse of 5/12. And since I've now completed it, x is by itself now. This is just an operation to do in my calculator. So I take my calculator and I find wherever my cosine function is, and in almost every calculator, at least the ones I've seen, it's above this button. The inverse cosine function is tied to this button. So the way I access this blue function is I come up here to my second symbol and I hit that. And then I press cosine and notice that my function now has the -1 exponent on it. And then I just enter in what I see here, 5 divided by 12. And hit enter. And if I were trying to use my cellular device as a calculator, the same process holds. I would just tell it, oops, if I see cosine here, I don't want cosine, I want the inverse cosine. So I press the second function that turns this into an inverse cosine. And because this calculator works backwards, I'd do 5 divided by 12 and get that as a decimal equivalent. and then press the inverse cosine. And that would get me my value. This tells me that x is approximately 65.3756816 degrees. I only want it to the nearest hundredth. So I'd look at the 7 and say, does this 5 push it up closer to 0.38? It does. So x would be about 65.38 degrees in this case. And that's how we use trigonometry to solve for missing angles.